How many stars are there in the universe? It's a question that has captivated humankind for millennia.
The answer, like the universe itself, is almost impossibly vast. Our Milky Way galaxy, a swirling collection of billions of stars, is just one of billions upon billions of galaxies scattered throughout the observable universe.
Think of the night sky. On a clear night, far from city lights, we might see a few thousand stars. Each a distant sun, some larger than our own, some smaller, scattered across unimaginable distances. This is the question astronomers sought to answer with deep field observations. By pointing powerful telescopes like the Hubble Space Telescope at a seemingly empty patch of sky for an extended period, they could capture light from incredibly faint and distant objects. It's a profound reminder of the vastness of the cosmos and our comparatively insignificant place within it.
Imagine you're standing on a beach, looking out at the ocean. At first glance, all you see is a vast expanse of water. But if you take a closer look, perhaps use a pair of binoculars, you'll start to notice details. The crests of distant waves, the glint of sunlight on the water's surface, maybe even a distant ship on the horizon.
Deep field observations are like using incredibly powerful binoculars to peer into the depths of space.
The fainter an object, the longer a telescope needs to observe it to collect enough light to create an image. This is where deep field observations come in. The longer the exposure, the deeper the telescope sees into space, revealing galaxies and other celestial objects that lie billions of light years away. These observations are crucial for understanding the evolution of the universe.
In 1995, astronomers embarked on an ambitious project using the Hubble Space Telescope. They pointed the telescope at a seemingly empty patch of sky in the constellation Ursa Major, a region devoid of any bright stars or nearby galaxies.
This region, equivalent in size to a grain of sand held at arm's length, became known as the Hubble Deep Field. Over 10 consecutive days, Hubble captured light from this tiny patch of sky, accumulating hundreds of images that were then combined to create a single, stunning image.
The Hubble Deep Field, unveiled in 1996, revolutionized our understanding of the universe. The image was breathtaking. In this seemingly empty patch of sky, Hubble revealed thousands of galaxies, each a swirling collection of billions of stars. The Hubble Deep Field showed that the universe was far more crowded and complex than previously imagined.
Section 4. Cosmic Distances, a playground of light and time. To truly grasp the scale of the universe revealed by deep field observations, we need to wrap our minds around the concept of light years.
A light year is the distance light travels in 1 year, which is about 5.88 trillion miles or 9.46 trillion kilometers. When we observe a galaxy that is 10 billion light years away, we're seeing light that has been traveling through space for 10 billion years.
This means we're looking back in time. The light from distant galaxies carries with it a snapshot of what that galaxy looked like billions of years ago, when the universe was much younger. Consider the Andromeda Galaxy, our closest galactic neighbor. It's a spiral galaxy, much like our own Milky Way, located about 2.5 million light years away. When we look at Andromeda through a telescope, we're seeing light that left the galaxy 2.5 million years ago, long before modern humans walked the Earth.
Section 5. Echoes of Creation, Peering Back in Time. Deep field observations have provided astronomers with a powerful tool for studying the early universe.
By observing the most distant galaxies, we can effectively look back in time and study the universe as it was billions of years ago.
One of the most significant discoveries made possible by deep field observations is the evidence for an epoch of rapid galaxy formation in the early universe. Astronomers have found that galaxies in the early universe were smaller and more irregularly shaped than galaxies today. These observations suggest that the early universe was a dynamic and chaotic environment, with galaxies colliding and merging frequently, triggering bursts of star formation. Deep field observations have also provided insights into the nature of dark matter and dark energy, two mysterious components of the universe that we can't directly observe, but whose influence can be inferred from their gravitational effects.